Hey guys, it's Kate. If you don't know, that's who I am, and I love to get on here and share all kinds of things. One that I want to share about today, Krista Juliana posted about it. It's about viruses and proteins. And if you know, and most of us know what's happening in our world right now, you understand why this is so cool and so important for us to know. And one reason why I think fulvic acid is going to blow up and is already, I actually just listened to a naturopathic doctor and a chiropractic doctor talk about, they were just doing a question and answers, and fulvic acid was brought up briefly, and they said, wow, I'm new to the game of folic acid, but it looks like it can treat almost anything. So cool. So what I want to say that about that is, how cool is it that I think what's happening in our world is why it's kind of been all of a sudden like, wait, it's got attention, but now we're looking at it, and not only can it help with viruses, but it can actually help with so many things. And so really, really cool to be a part of Boo, and knowing that we actually have such an incredible product here. It's not like any other fulvic acid out there. So that's awesome. So with that said, I wanted to talk and explain why it helps with viruses and proteins and what the protein has to do with it. Okay. So when a virus gets into our body, all right, the first thing it wants to do is it wants to make more of itself, right? It wants to kind of take over, and it uses our own body against ourselves. I say that by saying this, is that what happens is it goes in and it finds a cell. It has a protein on the outside, the S protein, and it goes and it finds on our cell where it can kind of almost like a lock and key. It goes, it attaches, and once it attaches itself, it's allowed into that cell, right? Because our cells have natural barriers that that helps protect us, right, from things. But what it does is attaches it. Once it gets inside the cell, in the cell, it actually makes more of itself, right? We call it replication. And then what it does is, as it leaves that cell, it takes some of the genetic material, like envelopes. Not every virus has an envelope around it, but the ones that do, it actually takes this genetic material of the host and surrounds itself with it, so that the immune system has a harder time identifying it and killing it, right? So it can survive, it can go, it can attach to more host cells and continue on and continue on. We know with the current virus out there that one of the big issues is that it's attaching to different cells in the body, causing a lot of horrific issues, okay? And so the cool thing about humic acid is it has been known for years to be antiviral. And how it does that is this, is that if you think about the way a virus, we talked a little bit, I don't know if anyone else saw my video, we're talking about how there's positive and negative charges, and how certain things, when they are the opposite, a positive charge, negative charge, they want to bind, they want to attach, okay? And so that's a little bit about what we're seeing here. We have a positive, it's almost like a magnet, right? Anyone played with magnets where you would see, like, if you try to put the two positive ends together, they kind of reflect. If you try to put the two negative ends together, they repel each other. But when you put a positive and negative end together, they attach, okay? And the stronger that attachment, the harder it is to remove that once it's attached. So that's going to be important to understand what it is that's happening. So the protein, the S protein, is what's attaching and allowing these viruses to go in, replicate, and infect bodies and cause a lot of the issues. What humic acid has been shown to do, and fulvic acid is a type of humic substance, right? What happens is that it's a polyanionic, which basically means it has negative charges, and those negative charges attach to the positives on the outside of the envelope, on that envelope of the virus. And those are what are needed to attach to the cell so that they can replicate. So if they cannot attach, they cannot go in, they cannot replicate themselves, cover themselves with our genetic material, and move on and continue to grow and grow. And so what happens is not only does the humic acid attach to that to make it so that it can't bind, but then it also alerts the immune system that this is not meant to be here. So that little sneaky trick that they do where they try to cover themselves with our genetic material so that they can't be seen, fulvic acid actually takes away that ability and identifies it for our immune system so that our immune system can get rid of it. So what this means is that it's an incredible preventative, right? Because if we have fulvic acid in our system, it's going to keep viruses from being able to attach to the cells, grow and replicate, and cause us to get really, really sick. Now, for people who already have an active infection going on in their body, it cannot necessarily, once it's been attached, right, do anything once it's attached. However, if you think about the way a magnet is, okay, if you have a negative and a positive charge here, but let's say that magnetic charge is kind of weak, and there's something else that comes along and it actually is so much stronger, it has a stronger pull to that, it can actually push out what's already attached and attach itself. Okay, and so that's what we talk when we talk about affinity, the affinity that a substance has for another, or a charge has for another charge. Okay, and that's what they also see with fulvic acid, is that actually it has in some cases been shown to have an actually higher affinity for the virus than the virus has for the cell host, and so it can actually displace that virus from the host cell and attach to the fulvic acid. Super cool. And so different studies that have been done, they've seen it in HIV, they've seen it in influenza, they've seen it in Coxsackie virus, they've seen it in the Lyme, the tick-borne encephalitis viruses. They've seen it in herpes simplex, okay, virus. So we know that in multiple viruses, it has shown, in the very least, to prevent it. But in some cases, it has shown that the affinity, right, that strength of that pull, the affinity is actually higher for that virus to want fulvic acid than it does the host cell. And so it can, in some cases, actually displace that. But one, we know it keeps it, once it's there, it keeps that virus from being able to bind to the host cell, replicate, and do all the badness. If it's already done it, the other thing that it can do is that even if, let's say, you already have an infection going on in your body, once, remember we talked about how it goes into the cell, it makes all its new little babies, and then they leave, right, covered in our genetic material. Well, now the new stuff that comes out gets blocked by the fulvic acid. So whether or not you're doing it for a full prevention, or can be used therapeutically, meaning that it can be used once that virus has already been done, because the way a virus survives is by continually to latch onto your host cell and replicate itself and come back out. And so it's that second or third group, or wherever it is in the cycle of your illness, that you go and you start using fulvic acid, can help decrease the amount of new viruses, and it also helps, like I said, identify those viruses for our immune system. So very cool stuff. If you haven't read the article on it, I highly recommend that you do. I hope that this was helpful for you in explaining kind of how fulvic acid can actually work in this way. Anyways, I'll talk to you guys later.